Hello everyone, my name is Adrian Garcia, and before we start, I want to ask you a question. Have you ever had a hard time picking out a ripe fruit based off of its color? Or have you ever had a hard time telling if a traffic light was red or green? If you answered yes to either of those questions, you could be colorblind. Color blindness affects about 300 million people worldwide, and today I wanted to break down what's actually going on inside the eye, why it happens, and how people are using bioengineering to get around it. First of all, the problem. When most people imagine color blindness, they imagine people seeing everything in black and white. That's actually very rare, and what's most common is red-green color blindness, which is what I personally have, and which was the main reason why I picked this topic. Specifically for me and many others, red, green, orange, and brown all kind of just bleed together. This affects about 1 in 12 men and about 1 in 200 women. This causes a lot of misinterpretation in a lot of different fields, such as graphs, cooking, and as I already mentioned, traffic lights. While in most situations it probably won't be particularly dangerous all the time, it could be a very big hindrance to you if you're trying to work with colors. Particularly in a lot of fields such as aviation, electrical, and lots of parts of medicine, being colorblind can actually disqualify you from the job entirely. And the reason that this is interesting for me is because from an engineering standpoint, it almost comes down to a single gene mutation that can probably be easily fixed. So to start off with the biology, this is what's actually going on inside your eye. So in the back of your eye, you have two types of light-sensing cells. There are rods and cones. The rods handle low light and cones handle color. And of these cones, you have 3 different types. You have one for blue, one for green, and one for red. Color blindness almost always affects the red and green ones because those genes for the cones sit on the X chromosome. This is why it affects men more, because men only have one X chromosome. So if there's one broken copy of that gene in the X chromosome, the whole cone typically doesn't work right. And since women have a backup, that's why they're less likely to have color blindness. So what ends up happening is that the green and red cones become a little too similar, and they start picking up overlapping ranges of light. So when you have red and green light hit your eyeball, your brain kind of gets the same signal from both of them, and you can't really tell them apart. And this one gene is what engineers are trying to fix. So right now there's about 2 main approaches, and they're somewhat different. The first one is through gene therapy. And the idea for this one is pretty simple, because if your cone cells have a broken gene, delivering a correct one to them and having them start producing the correct one would just fix them. And so the delivery method for this is through a modified virus, where they strip out the harmful parts of the virus and load it up with a healthy gene. After that, they inject them into your retina, and the virus gets into the cone cells and injects them with the healthy genes. And once your cell starts reading these new genes, it starts working correctly. The other method is through N-chroma glasses. These type of glasses are already on the market, and you might have already seen them in YouTube videos of people making huge reactions to finally being able to see colors for the first time correctly. I know some influencers have done that in the past, but one of the main problems with red-green color blindness is that these two cones overlap so much in the way they respond. So what N-chroma lenses do is that they have a filter that kind of cuts the specific wavelength just in the right way, like in the overlapping zone, to sharpen the distinction between what each cone actually picks up. The N-chroma glasses don't actually do anything to fix the biology, and one of the problems with these is that they are also slightly a bit expensive, and they typically don't work for everyone. But they're popular enough and it works for enough people so that they're consistently sold on the market. For a societal impact, gene therapy in this sense could change a lot of lives, not just in a dramatic way, but by removing 100 of small daily frustrations, and maybe even opening up careers for people that used to be off limits because of their color blindness. The thing that hits harder in this is the cost. Gene therapies have already hit over $1 million per patient. So even if it does work correctly, who would really get access to it? Probably only the super wealthy, right? This is less of an engineering problem and definitely more of a policy one. So thankfully, since color blindness is understood very well engineering is just the right solution that we need to hopefully one day make it so that less people are colorblind. Thank you everyone for listening, and I hope you have a nice day.